In the next 3 lessons we're going to look at density. Now the density of a substance or an object is a measure of the amount of mass that's contained within a given volume. In a sense, it's a measure of the compactness of matter. That's to say, it relates the mass of a substance to the space that it occupies. So we can write a simple formula for density. We can say that the density is equal to the mass divided by volume. Now, strangely enough, the symbol for density, you thought it might be D, but it isn't. It's a Greek letter rho, which looks like a P, okay? And we can write that as equal to m over v. That's mass over volume. So the unit for density can be derived by observing this equation. You can see the units for mass is the gram, and the unit for volume here is the centimetre cubed, or cubic centimetre. So we can write the unit for density is the gram per centimetre cubed. It can also be written as the kilogram per litre, particularly if we're talking about the density of liquids. So density is the mass contained within a given volume. So let's just take a couple of examples. So imagine that I've got 2 cubic centimetres of different metals. Here I've got a cubic centimetre of potassium and a cubic centimetre of copper. Now if I measure the mass of these cubes, I will find that the mass of the potassium is 0.89 grams, while the mass of the copper cube is nearly 10 times bigger. It's 8.96 grams. So, substituting these values into the equation for density, we can see that the density of potassium, let's write that, pK, that's the density for potassium, is equal to 0.89 grams per cubic centimetre. While the density for copper, we'll write that as rho Cu, not P, rho, is equal to 8.96 grams per cubic centimetre. So what these figures tell us is this, that when we say that the density of copper is 10 times greater than the density of potassium, for example, then we're saying that 1 cubic centimetre of copper has 10 times more matter packed into it than 1 cubic centimetre of potassium. To understand why different metals have different densities, we need to look at the particle model, and we'll be able to understand why copper has a much greater density than potassium in the following lesson. Sometimes in physics problems, the density is quoted in terms of kilograms per metre cubed. So to convert from grams per centimetre cubed to kilograms per metre cubed, we have to multiply this figure here by 1,000. Okay, so we multiply it by 8.96. In this case, for copper, we multiply that by 1,000, and that gives us 8,960 kilograms per metre cubed. So 1 cubic centimetre of copper weighs 8.96 grams, 1 cubic metre of copper, which is clearly a lot bigger, weighs 8,960 kilograms. Likewise, the density of potassium will be 0.89 multiplied by 1,000, that's 890 kilograms per metre cubed. Now finally, in this lesson, I'd like to talk about the density of water. Now, water is a liquid, so we often use litres rather than cubic centimetres, and we say that the density of water, that's rho water, is equal to 1 kilogram per litre. And we could also write that as 1 gram per milliliter. And we remember that 1 milliliter is exactly equal to 1 cubic centimetre. In other words, 1 gram per milliliter is equal to 1 gram per cubic centimetre. Now you might say, what a strange coincidence that the density of water, such a common and important substance, should be exactly 1. It's not a coincidence. The reason for that is because the density of water was arbitrarily defined by scientists way back in the beginning of the 18th century, or something like that. And so what they would have done is they first of all would have defined the meter. Okay, I believe this was French scientists, and then they would have defined the centimetre, and they would have defined, for example, a cube that is exactly 10 centimetres cubed. Okay, this is a container, right, which has for its side a cubic container which has for its side 10 centimetres. That is called 1 decametre. That's a cube of 10 by 10 by 10, and it's equal to exactly 1 litre. Okay, they will have then filled that container with water and would have said that the mass of the water in that 1 litre container is equal to exactly 1 kilogram. Hence they will have defined the kilogram using metric measurements. So what we're saying is that the density of water, that is 1 gram per centimetre cubed, is not a coincidence, but rather it was arbitrarily chosen or arbitrarily defined by scientists, and is thus used as a reference point to measure the densities of all other materials. This is not unusual with water. For example, scientists did exactly the same thing, you remember, when defining the Celsius scale, where they used the melting point of water, which is where they set the melting point of water as 0 degrees Celsius and the boiling point of water as 100 degrees Celsius. These figures were chosen by scientists. They weren't measured as such, but they were chosen by scientists, and from these figures the Celsius scale was defined.